Today we will continue on and talk about the extension of things like pattern matching that we've been doing. And we will basically dive into what else can we do uh, and what else are available beside the option, right? Remember options that we learned from Tuesday. If you kind of forgot about it, let's do a quick recap, right? So we talk about functional language, right? We talk about scalar, we talk about applying functions, we talk about basically the way you can define definition of the function into an expression. An expression would reduce to a value in many cases, and functions are first-class citizen, right? And then we talk about things like pattern matching, which give you the benefit of give warnings, making sure you don't have duplicate cases. In the end, make sure the program is more organized and also hopefully uh, more. I don't want to say more correct because by default you should have a correct program, but it's easier to spot bugs. That's how I should put it. Yeah. And you can do things like breaking tuple down to a list, breaking tuple in a list into just the variable, i.e. the expression or a name. Then we talk about the option. Option is, well, as the English word implies, you have a choice of either have nothing or something, right? Something inside the option. And then we talk about tail recursion, which basically another form of using a recursive function, but instead of a typical recursion, right, a tail call will accumulate partial results, which give you the benefit of like recycling the stack frame. Hopefully, you don't end up with a lot of like dangling variables that are defined, dangling expression that are not evaluated, despite the fact that they can be evaluated, right? And this gives you a nice compilation process into the iterative programming like C and Java, with, without a lot of additional states for each of the stack call. And why are these important? I kind of like stressed the part about compiler on Tuesday. On top of it, right, this is a lot more friendly to the optimization you can do in hardware because they are defined and designed actually for iterative program. So, in the previous example from Tuesday, we used this thing called products or sum as an accumulator. Basically, these are kind of like a temporary variable if you would like to think about it that way. And it kind of accumulate the answer so far instead of waiting for the call to return. Right? So that's the concept of tail recursion. Today, we will talk about one of the really important things in functional programming, actually. It's actually important for all programming, and you might not have realized it. This is a concept called mutability. Anyone here have never heard about this terminology before, mutability? Can you hit like some emoticons, or I know you're still there, heard about it before, haven't heard about it before? Anyone here have heard about this terminology before? Oh, you did. Okay, awesome. So mutability, if you look at the root of the word, basically it's come from mutate ability, right? What's mutation? Let's go back to our high school biology. What does it mean for something to mutate? Right, long awkward pause. Anyone? What does mutate mean? To change. Awesome, right? So it's the ability to change. So the component of the programming language, if you think about it, we talk a little bit about the word syntax, and you might have seen this when you try to run a program and say, hey, syntax error. This is Syntax govern how you can write a language. Basically, if you look at language like English as a language, then the syntax would be grammar. How to use the articles, how to use the subject-verb agreements, how do you use the pronouns, right? These are the syntax. And why do we care about the syntax? Because if we say some gibberish, the computer doesn't have the ability to figuring out our gibberish, right? They don't have the human brain capability of trying to figure out what you're trying to say. So let's say I throw some random Thai guy into the United States, right? He should be able to say some, well, to be frank, broken English, right? And the people in the United States should roughly be able to tell what he's trying to do, right? But that's human brain. We are capable of kind of fix the syntax and map it to a meaning. Computer doesn't have that. So it means that whenever you write something, you have to be absolutely correct. For example, in Java, right? In Java, I think you all used Java before. What do I have to do the line after the if else statement? So I do if something. What do I have to make sure the line next line have to have to make sure that's the inside the if block? The block thing, the curly bracket, I mean the tab, right? The tab thing. You have to make sure you indent the whole block into another level in Python. In C, that's the bracket, right? Why do you have to do that? You give the computer a meaning to what do we do with that bracket? So that's the syntax. Semantics is what do program mean? You write a code. What does the code try to do? A Fibonacci code function will actually means that you want to compute the Fibonacci of n, right? Idioms is this is kind of the same as English language idioms. Basically, these are the typical pattern for using the language to express computation. Think of it as an English language idiom, same meaning, but for programming language. So that's why we call it idiom. Libraries are the facility, right? So what do we use library for in real life? We use it as a reference. You want to learn new things, you go to the library, or I mean, back in the old day, you go to the library, read books, and hopefully you learn new things. Again, but yeah, that's a great question. What is PL? PL over here stands for programming language, basically. If you, so this is a slide that I asked more like a rhetorical question, right? Hey, I want to invent a new programming language. What do I need? Anyone here ever wondering that before? Actually, think about it. How do someone come up with C? How do someone come up with thing like Python, right? How do someone come up with the English as a language, right? Everything language related. What do you use language for? In general, to communicate, right? We use English, Thai, or any language for human so that we can communicate between people to people, person to person. The same thing is with the computer, right? Back in the old days, if you watch the movie, like in the 60s or 70s, how do a programmer program your a computer? Anyone seen those before? And anyone want to take a guess on how did they program? Well, those back in the day, you just use wires, right? You plug things in, run it, hopefully you get results, right? Remember the, like, for example, imitation game, right? They actually use plugs. Right? If you watch imitation game, one thing that you might notice is that big spinning machine, right? They have plugs that someone need to plug in and out, right? And that those are electrical circuits. Those are back in the day how you program it, right? But with the invention of the programming language, now you can write something, the computer would know what you want them to do. Somehow it simulates this electrical circuit that happen inside the computer, generate the results that you want to look. It's a giant, huge, and really, really, really fast calculator, right? It's just a flat, really fast calculator. Uh, and library, okay, go back, right? Library are basically the facility that is available in your computer to provide features like how can you interface with the monitor, how can you interface with keyboard and mouse, how you can interface with printf, right? Anyone here use printf before, or anyone here never used printf before? I don't believe anyone here, well, I mean, unless you copy out the homework, right? You will have to use some form of printing before. Printf is another common library that would actually talk to your screen and say, hey, put those on the screen, right? Tools, or actually, for example, another set of library would be, anyone here use C++ before? Assume you all through data structure, right? So things like Java, C++ has a built-in library for tree, linked list. I think basically every basic data structure you can think of, like hash map, for example, they'll have one for that. You can actually use it. You don't have to implement it on your own. These are also a part of the library. Tools, what is defined? What makes your job easier? Things like a debugger, like REPL interface, right? GDB in C language, the debugger for IntelliJ. Sorry, I was looking for IntelliJ. Those things are tools making you develop faster. And one more thing, which is a component of things that go into your language, is the concept of what's mutable and what's not mutable, right? So at this point, if you've been playing with our in-class exercise, right, you might have realized you can modify the list somewhat, but the name that bind to the old list, the name that you declare that bind to the old list, still point to the old list, right? It still point to the old list. Everyone here know the concept of object, right? Raise your hand if you know what's an object. Java basic object, used it before, right? Somewhat. If you name an object in Scala, it's bind to that forever because it's not mutable. When you modify the list, you basically keep the old list and create another new list. So you get a new list. So that's what it means for a list to be immutable. So basically that's what it means. So let's say I name something X, and X is mapped to a value. Let's say 1, 2, 3, right? The name X will be forever mapped to this list, and nothing will change X such that, I mean, basically X cannot be mapped to a different list, right? Now, if I say just this, anyone, can you raise your hand if you feel like you hate this concept? Like why? Basically, anyone here ask the question, why? Somehow you think this might be a cool thing. And I think the first reaction for many, many people is, well, why? I just want to modify my list. Give me the new list. Why do I care about the old one, right? But this concept allow you to make sure that whenever you refer to X, it's still the old thing that you declared before, right? It's still the old things you declared before. So if you kind of like, if you want to actually prove the correctness of your program, and in that proof, you mention X. What can you guarantee? So you want to mathematically prove the program is correct and do the function you intend to do. If you put in the name X, what does it mean? What does it guarantee, actually? What does it guarantee? So if the list is immutable, if I say X, what do I get? from the slides here. If I say X, what will I get? Should I kind of repeat the? Yes, exactly. It should be just this list of 1, 2, 3. Whatever I do, whenever I say X, I get the same thing. Which means it's much, much, much easier for me to prove correctness. Right? Basically, it's easier to make sure your program are correct because there's no random thing that will modify X. If I modify X, it's a new content. I have to find another name for that. So generally, we have to construct and build this compound data. And if you want to access the element of X, you also have to kind of find a way to access them. You cannot just mutate the data we built. Right? So that's the big difference between mutability and immutability. And here are the benefits. You can guarantee nothing that you do in your program would modify the value, right? Which means that well, when random things happen, your code will still be correct if you cover all your base. Basically, if you kind of cover all the possible cases, then you're good, right? No one can modify existing lists. So let's go through some example, right? Uh, if I define this function sort pair, right? So think about it this way. If I run sort pair, right? Uh, if I run sort pair of 5 and 10, do I get the same pair? Or does sort pair actually create a different pair? Looking at the, by the way, hint is look at the code. Do I get the same pair? Or is there another object called 5, 10 inside my DRAM, I guess, inside the memory, the CPU memory? Okay, to approach this question, where you go and look into this if-else condition, is that a true or is that a false? It's true, right? So you return itself. Yep. Basically, there's an object that consists of a pair that has the value 510, and I return myself. So I get the same object, right? Basically, there's no new thing created. What if I say sort pair 10, 5? The question is now the if condition is false, right? The if condition is false, which means that inside the memory, there has to be some name mapped to 10.5 and another set of name mapped to 5.10 because you return another pair. It's not like you modified 10.5 into 5.10. There'll be one object that has a pair and the pair is 10.5 and another separate object which consists of a pair which has a value 5.10. Right? So that's one example. This, what does this do? So what's the difference between sort pair and sort pair 2? Can someone tell me the difference between the two functions? It will always return new object. Awesome. Yes, basically sort pair 2 guarantee that if you call this function, I will have a new separate pair. It won't be the same pair. If you look at the location of that addresses, someone call me. Let me pick up the phone quickly. All right, sorry. Okay, so sort pair 2 will guarantee to return a new object. All right. The difference between the two is basically if a pair is mutable, if somehow I have a language, let's say I assume scalar is mutable, there's also a chance that sort pair 1, you get the same object, right? For both of them. For language that allows mutable data, for a language that allow mutable data, the two functions would behave differently. It would behave differently as you suggest. It returns a new object for sort pair 2, and for sort pair 1, you might not get a new object. Second example is concatenate, right? So let's assume our list is 1, 2, and our second list is 3, 4, 5. The difference, if we assume mutable is allowed versus mutable is not allowed, is this. So let's do our first case, right? Mutable is allowed. If mutable is allowed, what will happen is I'm going to start with ys, right? So ys is 3, 4, and 5. So that's my ys. Right? What will happen if I do xs.head colon concat xs.tail ys? Basically, I'm going to plug in 2 and plug in 1. See how actually the function will then modify the content of ys, right? The function, if mutable is allowed, which is this case here, mutable allow is the first case. It means that ys would have 1, 2, 3, 4, 5. xs is basically 1 and 2. You ended up with a different ys. Right? The list is actually different. If you call ys, you have a longer list. If mutable is not allowed, this is what will happen. Ys stay the same. 3, 4, and 5. xs is the same, 1 and 2. And when you run this function, what will happen is there's going to be another intermediate data that gets spit out, which are 2, 3, 4, and 5. And then the return value would become 1, 2, 3, 4, and 5, which you can name it anywhere you want, right? So you can say def temp equal like concat xs ys. This means that temp it will become a totally new object that consists of a number 1, 2, 3, 4, 5. xs has the same content, ys has the same content, right? So remember, scalar is most variable unless you force it. Most variable and definition are immutable. Right? The reason I want to say that is because actually when you play with scalar, there's another potential error message you might get when you compile your code because they say, hey, this thing is immutable, and you try to modify it. I'm not gonna let you compile. Make sure you assume that things are not mutable. Any question before we move on to the next topic? All right, reminder, we have in class exercise 4, which this thing, we will go back to this after we're done with the lecture portion of this class. Use tail recursion to do these things. Now let's move on to another set of topics that are more pattern matching, right? And one thing, oh, actually we learned multiple things. What is a list? Can someone define a list for me? What does it mean if I create a list? What are the key properties of the list? It's order mutable object. Okay, that's great. That's a perfect. It's an order correction. Both of them are great definition of a list, right? So if you want to generalize it, these are something that you can extend, right? You can keep adding stuff to it. Any anyone want to come up with their own version of this data type? Okay, what are the thing that you can keep extending? If a set behave in a similar fashion, it doesn't have to be order. I just want to make sure I stress the part about you can expand the content. So is does the set has the same property? It's collection of items, right? Is that a kind of like roughly the same property, assuming that I don't care about ordering? Yes, no. How about a tree? Yes, and a special property of the set that the list doesn't have is set you don't have duplicates, right? The list you can have duplicates, so they're different thing. What about a tree? A tree is also something similar. You can keep adding things to a tree, right? So these are called compound type. Specifically, right? Specifically, this is called product type. A value can contain many things. A predefined type. They have to have the same type, right? Example of this is tuple. You can have a sum type. What is a sum type? A sum type is, oh, actually, no, a list is not a product type. A product type is something like a pair, a tuple, a well-defined fixed size. Now, this is how to have fixed size, same type, right? A tuple is a product type. A sum type is something where you can say each of, not, one of, things like an option. The value can be one of the many types, but you only have one value. So let me kind of summarize it. This is one value, many types. Many value, but fixed size. One type. With me so far? Basically, product type means that I know the size. It can have many values, only one type. Some type, one value, many types. What's the example of that? We've just learned about this last Tuesday. What's the new data type that we learned? That can be none or sum of a value. What's that called? The option, right? The option. So that's an example of sum type. And recursive type is something that make a recursion to themselves. These are the things that you can expand. Things like a linked list. This has to have a multiple value. Well, it's a value that can refer to the same type. This is something like a linked list or a tree, right? A tree can point to the next tree. A list can point to the next list. The element points to the next item. That's why we call it recursive type. With me so far? Anyone here would like me to repeat this thing again? Because I feel like I kind of failed the first time I did it. Okay, awesome. So you can have collection of items, right? So let's look at the universal thing as just collection of items. And let's define this compound type. Compound type is collection of items, right? With me so far. Basically, there can be a data structure where I define that it will collect many items. Things like a set, a linked list, an array, right? An array is also another legit item collection, right? With me so far? And what I'm trying to say here is let's actually classify this into three types of collection. And the first type of collection is something like an array, a tuple. So what's the property of a static array? Let's say you declare an array in C or in Java. I say a bracket 10 equal and then initialize the value. What do I know by default about A? This array A. And you know the size, right? You know the size and you know the type. It can be an array of integer. It can be a tuple of integer, string, and integer, right? With me so far, so these are the product type. It consists of many, many things. And it's a strictly predefined one type. This one type can be a pair of int, string, right? Which is one example of like one hello, two hi, right? Those kind of thing is a product type. With me so far? Then, right, then the sum type is this sum type can only contain one value, but that one value can be many, many types. An option is one of them because it can be none or sum of the value, right? So we call this a sum type. And a recursive type is basically a data type, a compound data that can make a reference to itself. Why is a linked list reference to itself? How do you build a linked list in Java? What does a node in a linked list typically consist of? A pointer, right? It points to the next item. So you have the value of the node and the whatever. Well, in Java is basically the next object. In C is the pointer that points to the next node, right? It make that reference to the same data type. That's why we call it recursive compound type. Because linked list will point to the next list, the node will point to the next list, the node will point to the next list, the node will point to the end. Right? A tree is also a recursive type because it points to the child. The child then points to another child, right? With me so far? Awesome. The other thing I kind of want you to understand is you can also make an alias for a type. What does alias mean in English? It's like an alternative name, right? So you can define an alias of a type. For example, I can define type in scale. I can type this thing in type person string double int string. This basically means that whenever I use the type, if let's say if I call x colon person, now the type of x is person, and the type of person is basically it's a tuple consists of a string, double, int, and string. Okay. And this is actually make it less annoying, to be honest. You don't have to always type string double int string. But the still annoying part is you kind of still need to remember what go into what order, right? Remember, tuple has an order. So the string is likely, the first one is likely to be the name, right? Uh, what should I use a double for? Help me, something. Yes, I'll do height. And the last string is an address, right? Let's say I want to somehow store this full information about a person. You have to make sure you put the name in the beginning and the address at the end. You don't put the address in the beginning and name at the end because there's a strict ordering, right? And you need to go what value should go into which order. The first entry, well, actually, to have this on my slide, my bad. The first entry can be a name and the height and age and then, yeah, address, right? So this is annoying because you need to exactly know the order you have to input for your input type. That's why the concept of record comes into the rescue. It actually kind of like designed to address the problem that we just discussed, right? So you can create this concept of a class. But by the way, quick question: you went to object-oriented programming before, right? That's a part of the data structure. Am I correct? Yes, no? I think, right? Okay. Uh, what is a class? Help me define what is a class for everyone here. Yeah, it's kind of like an object with a constructor and you can initialize, right? And you have function tied to that. So the concept of a record is similar. It's like an object that you define in the beginning. You can create this record. It's a type-ish, right? It behaves almost like a type. Uh, if it's a case class, so if you in scalar, instead of type person equal string double int string, you can say case class person name colon string height colon double age colon int address colon string. This basically make a record for a person, and to use it, basically you can do something like this: person John 18030 Thailand, right? It basically means that you put things in a correct order. You make sure you put things in a correct order, and this is one way you can initialize, right? This person called John. You can do person height equal 1.8, address equal Thailand, age equal 30, and name equals John, right? This is another way you can use the record. Now that you know, okay, 180 is the height, I will make sure I bind the variable height to 1.8. You can also bind a name to record. For example, val p1 equal person John 180 30 Thailand, right? And you can use the field name, which is p1 dot followed by the name bind to that value, right? It can be name, height, age, or address to access each of these fields, right? You see how this basically similar is basically this is similar how you do object-oriented programming in Java. Yes, no, it's the same thing, right? So while to be frank, right, these things are immutable, but think of it as there's a really close analogy to how you use object in Java. I think it helped with really like remembering how you use record, right? Think of it as class and object in Java, and you do case class, the name of the record, followed by what goes into it, right? And then you can with the way you can reference thing, right? There are way to reference by name and reference by position, right? Now that you have inside the record, there's the name, height, age, and country, right? So you can access those names and heights and country by either reference by name or by position, right? This this is actually kind of different for each languages, right? You can have a hybrid approach as well. For example, if I use Java and I call a method, right? How do I call a method in Java? Can someone type in a sample of a way I can call a function in Java? Yes, exactly, right? Some object dot some method, right? And then you put X and Y and C. Do I have to make sure X and Y and Z are in that exact order? What if I put in Y and X and Z? Right? What if I put in Y and X and Z? It might not work, right? Buggy code, because you need to make sure you know the exact order. That's why I say caller. Caller is when you call the function, you use the position. You want to make sure you put in the right thing in the right order. But callee is when you declare this function, some method, right? Inside you would do int input one, char, input two, I don't know, int input three, right? And inside the function, you would do input one, I guess input three equal input one plus plus, right? So inside the function definition itself, you use a variable name, right? You use a variable name. So in Java, it's a hybrid approach where when you call a function, it's by position. But when you take the callee, the person that receives the function call, you map the value to the variable name and you use the variable name afterward. Python, by position is required for an argument and by name is optional. If you have optional arguments in Python, you can do something like a function call, right? Test one, two, and then A equals 10, B equals 20. What do I do? What will happen if I call a function in Python like this? It basically means the first input will get the value 1. The second input will get the value 2. The optional variable called A will get the value 10. The optional variable B will get the value 20, right? And the rest get the default value. So that's why each of the language would use the way you reference in a different way. It can be by name, it can be by position, and it can be a hybrid of the two. Right? Any questions so far? Any questions so far? Because if not, let's move on to the next topic, which is now that we learned that the existence of a sum type and one of it is an option, basically let's create new sum type. Let's expand our exposure to sum type beyond just an option. So what if we want to create our arithmetic expression that involve addition and multiplication? I can do something like this. Basically, the keyword trait here. Trait. It means I want to create a new sum type. And this new sum type is called expression, EXPR. It's going to be any name. Basically, you can do trait and some name. This is just the name I put in here, right? Inside, the keyword I have to put in for scalar is case class. It can be case class or case object. We'll learn case class for now. What does a case class do? Basically, when you say case class and this is the name when you use class constant, when you want to use this class constant, you have to basically, this would dictate that there will be one input. And this input will have the type double. And it would extend my definition of expression. So it basically say, hey, expression, EXPR can be of this format, which is a constant. Say, for example, constant 5. Right? It would mean that my type EXPR right now has a constant 5. And the second type that you can take is instead of a constant, I can have negation. I can do negate -10. This is still a possible type that EXPR can take. Right? What else? What else can I have EXPR do with this particular definition? The other one is called sum, right? So I can have a sum. What should go into the type that goes into sum, which I define here? E1 and E2. What's the type of E1 and what's the type of E2? EXPR, right? So is this a valid format? Is this valid? Can I say sum would be sum 5 and -10? Close enough, actually. So 5 is an integer, right? In fact, it's a constant. But 5, the type of 5 is an integer. And EXPR, because at this point, I didn't define what do I do if it's an integer. I can say, I can have another case that say it's an integer. But as of now, it only knows that I will have to have EXPR in there. So to make this valid, I would need to change this to what? So I would want to have number 5. What do we put in here? Constant, right? 5, right? So I just do constant 5 and negate -10 because that's an expression, right? With me so far? Should I repeat again? Why do I have to do constant 5 rather than just the flat number 5? The reason behind that, because I specifically said the input need to be the type expression, and the type expression doesn't know what do I do with integer. So you have to have the term constant that basically plug in there. And product is the same. Basically, you can do product constant 5 negate -10, right? And the extend ESPR basically means that this is an extension to my definition of this type, right? Now that you know option, what does option do? So if I want to create my own option, right, it's basically something like this. So what would be the first case? What do, what do I put in the first case? So I do case what? Well, actually, specifically, this is the case object. But what do I put in? It's none, right? And then extend option. Then you do case class some n, which is a type extend option. This is how you can manually create a type called option, which is the same option as we learned from Tuesday. It can be none, or it can be something, right? And basically, let's break this down a little bit, right? We give you an example of EXPR, and it can be one of the following. It gives me a constant with a value n. It can have a type double, right? It can be a sum of the two expression, a product of the two expression, and I forgot one thing, a negation of an expression, right? So with this, right, let's do another example. Let's do another example that would hopefully make things a little bit more clear. Anyone here play cards before? Like playing cards? It can be any type of games, but you've seen it before, right? So what does a deck usually have? A number, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then there's a jack, queen, ace, and king, right? So I can create a trait called a rank, right? And I say, because there's jack, ace, queen, and king, and they are just some name, right? So I just say case object. What is an, well, actually, let's just keep it for now. We will learn about what the heck is an object later, but think of it as it's a singleton thing. It's just one single thing. Whenever you said jack, it would mean this object jack, and everyone in the program, in that program that you're running, would then know that, okay, it's that object. You can say case object jack extend rank, case object queen extend rank, king extend rank, ace extend rank. And then for a number, basically case class num, so you can say num 10. That would mean you're looking at the number 10, the card with the number 10. Right? This would also extend rank. And now notice that we mix both the class and the object in this sum type. Right? The same thing as case object none extend option. Case class sum in parentheses value extend option. Right? So you can use the same concept to create the rank of playing cards. All right. Any questions so far? Okay, so as discussed previously, and you use pattern matching for some type before, which is an option. Right? I'm about to say an object for some reason. So you've used an option before. You can do the same thing with, say, playing cards, right? So let's assume our following example. We have trait expression EXPR, right? Let's assume we define EXPR. The first example is, let's say I want to evaluate this. I want to define a function called eval. The input is just EXPR, some expression, and it returns double. Basically, when I call eval on my expression, I can do something like eval constant 5, right? I can do eval product of constant 5 and constant 20, right? So what would this evaluate to? If I call eval constant 5, what do I get? 5. Yep, correct. So how about this? What should I get? I do product 520. It should be the multiplication of the two numbers, so that should be 100. All right, so the actual definition is basically this. Case, basically pattern matching, if my expression is a constant, right, return n, because we're done, yay, right? If it's a negation, if the type is negation, you basically return a negative value of eval e. You just apply negation to eval of e. You break down the negation. If it's a sum, you do eval of the e1 and eval of the e2 and add them together. If it's a product, eval e1, eval e2, and multiply them together. This basically gives you ability to return an actual value, because if you look at this, it would keep running eval until you have a constant, and that would give you double. Basically, at the end of the day, this particular function will give you a double. It will give you a value, right? All right, so let's do a second example. What do I just want to print an expression? So instead of evaluating the expression, I want to print the number on my screen. So I can say stringify input is an expression, but instead of returning a double, I return a string, right? And if I have a constant, I just return that number dot to string. I'll get a string back. I want to print negation. So in this case, I'll just add a negative sign to stringify negative e. A sum and product is the same thing. Stringify the left side, stringify the right side, and have the plus sign in the middle. Stringify the left side, stringify the right side, and have the multiply sign in the middle, right? So these allow you to actually print the expression expr. So you want to add these two things as one object. I can say an object expression eval. I can evaluate this. This is almost like a Java class. Right? Look at this object. It has multiple functions, and you can use it. Right? You can use it. So you can do exper eval dot eval, and something goes into input, or expr eval dot stringify input. Right? So both of them would be valid. All right. Any questions so far? Any questions so far? All right, so I think this might be, so to be honest, this part might be a little bit confusing. We are going to have an in-class exercise related specifically to this expression that will basically ask you all to implement your own version of this expression and make it work next week, actually. So make sure this week you finish up in class 2 to 5 during our Discord like practice run session after the lecture. I'll be there to kind of troubleshoot everything again, like usual. I definitely, because if it's a real like physical setting, I'll be in a room looking at your screen, right? And make sure everyone know how to do this. And this is actually really, really working really well for the first iteration of this class when we still don't have COVID. I would like to make sure that please stay with us during the Discord session. And you all did really well so far. You all did really well so far. But one thing I learned from system skill class last semester, about halfway through the midterm, you all left the Discord session. So make sure you know how to do this, right? And we have a practice run on this. And we have another thing is, what is it? In a typical switch case statement, right? You can have a default case. Same thing can be done in Scala. Basically, this is the default case. Case underscore. Case underscore. That's the default case. Any question about this? Okay, so again, pattern matching benefit. My code looks a lot less ugly. You get warning, and it works for option lists and many things that you define later. If you define a sum type and you do pattern matching and you forgot something, Scala would actually tell you. Okay, that's a great question. So the question on what does a default case mean? What does a default case mean? It basically means that you want to do pattern matching, right? And let's say your sum type has a type A, B, C, and D. It can be of any type, and A can be integer, B can be double, C can be a string, right? So with me so far? All right. So if you want to do pattern matching and you know if it's any form of number, like integer, floating point, double, just print the number. Right? Just print the number. And if it's a string, do something with it. Do something else with it, right? So the lazy way you can do this is case string, do something. Otherwise, if it's an integer, double, or floating point, do something else. It basically wrap whatever else this particular data can take form, do this. Otherwise, look at this pattern. If it match, do the rest that you define. All right, so that's why we call it default case, because default means that in computer programming, right, whenever we mention default is, it's kind of like, okay, do this by, well, I wouldn't say by default, but it didn't really define what the word default is. So basically, the generic case, you handle it this way. It doesn't match to anything, so go there. All right, we covered this. So now it's time for in class 5. It's already posted on Canvas. Basically, implement the following function. This is not specific to the thing we learned today, actually. I want to kind of like wrap up and make sure you're comfortable with functional programming first. So I want to implement two functions, zip and unzip. Zip has two lists, right? Two lists. And the list is just a list of number. Right? And it can be any length, right? And then you basically pair them up. The first number of the first list would get paired up into this. The second number would get paired up and give you this. And the third number would get paired up and do this. Unzip, reverse of that. Let's say I have this list, right? You just return the two lists. That's a great question. The question is, will putting just default case, will that give you an error? Nope, you can just have one default case and that's all. Because it basically covers all the possible cases that can have with that data type, right? So you can actually do that. All right. Okay, so I think I have one more slide, which is about syntactic sugar. Here. Nope. Do it manually, please. Basically, the question is, can you use the map keyword in the SIP? We will talk about map in a bit, actually. Please stay with us. So it's actually great that you asked that. And I would love to say yes, but for the sake of all your other friends, please do it manually for now. Use recursion. Basically, use recursion. Another thing that I kind of want to cover today is, yes, you have to change it. Oh, no. For in class two is fine. In class two is like use whatever you want to do. So in class two is a little bit special case. We have it there because we kind of thought that you play with this Newton method before. So in other classes, so we assume that you still familiar with it. So we can kind of like, hey, let's use this to transition you into Scala. And you can use whatever. So in class two is fine. All right. Okay, so syntactic sugar, the basic idea is if you look at the semantics of a program, sometimes it's hard to use. We want to make it easier to use. For example, instead of a typical tuple, right? Instead of typical tuple, why can't I create a pair using record? Because record is a little bit easier to deal with, right? So you can, and that's what we call syntactic sugar. You put sugar on something to make them sweet and hopefully easier to eat, right? If you want to feed something to a kid, you probably would trick them with anything with sugar, right? So that's why we call this syntactic sugar. Sometimes the syntax is annoying to use, so we wrap it up. This is the wrapper function. And you can do this in functional programming. We'll call this, basically when you do this particular example, we'll call it tuples are syntactic sugar for record, right? And sorry, when you use this syntactic sugar, it doesn't really introduce a new meaning. It's still a pair. If you look at that example, it's still a pair, right? So there's no new meaning. You just repackage it to make it easier to look and work on it. Actually, that's the basis of many concepts behind a wrapper function that we all use in programming. This is another element of programming language. When you design a language, well, you can allow syntactic sugar and make things easier to use as well, right? If you're in the system skill class, for example, everyone at some point will hate assembly. Uh, and the reason behind it is because it's kind of like obnoxious to use, right? It's annoying and no one wants to program in assembly. That's why we invent new language, which when I look at it, it's kind of like a wrapper for assembly, right? The concept of syntactic sugar is similar in the sense that you want to wrap something that has some certain features with something that's easier to the eyes. So that if you give the code to your friends who hasn't used a lot of Scala before, they look at the code like, okay, I at least think that I understand what you're trying to do. All right. So that's it for the lecture part for today lecture. We will actually now let's move on because we have four pending in class exercise. So let me stop the recording.